Offshore drilling rigs have all the functions of onshore rigs, but also need to stay on station in a variety of sea states and allow for secure connections between the surface and the sea floor. To start an offshore well, a thick-walled, large-diameter hollow tube called a conductor is embedded in the sea floor, with the aid of a bit that jets away the sediment with high-pressure seawater. When the conductor has penetrated about 250 feet, the jet bit is retrieved and a drill bit introduced. The cuttings are just washed to the top of the well by seawater pumped through the bit. A second run of conductor is now lowered into the hole. At the bottom of the conductor is a guide shoe that stops the conductor snagging on the well bore. Above the shoe is a flap valve called a float collar. A cementing tool is connected to the top of the conductor. A plug that pushes the seawater out is driven downwards by high-pressure cement that fills the conductor. On reaching the float collar, this plug is ruptured, and cement flows out of the bottom of the conductor and up the annular space between the wellbore and the conductor. The cement plug tool is removed, and when the cement has set, drilling continues with a smaller diameter bit, penetrating the cement plugs and float collar and into fresh rock. After a suitable depth has been drilled, the drill string is removed. Then steel tubing, known as casing, is lowered into the hole and cemented in place. This first casing run has an attached wellhead. A blowout preventer, BOP, a robust set of valves that can shut in the well even if the drill string is down the hole, is then lowered and locked onto the wellhead. The BOP is connected to the sea surface by large diameter tubing known as a riser, which allows drilling fluids to be returned to the surface. From this point onwards, the drilling procedures are similar to those used to drill an onshore well. With the riser in place, seawater is replaced by a special fluid known as drilling mud that is pumped down the string and exits through ports in the bit. The mud not only cools the bit, but also clears the cuttings from the hole. The cuttings are captured at surface and examined by geologists to characterize the rock types that are being penetrated. As drilling continues, sets of decreasing diameter bits and casing rings are used as the well penetrates deeper into the rock. Each run of casing is cemented in place to provide integrity, a sealed system from top to bottom. The density of the mud is controlled by the mud engineer, adding dense minerals when needed. The aim is to produce a column of dense mud which exerts sufficient pressure in the well to counteract pressure from fluids encountered in the rock. This combination of the dense mud column contained in properly cemented casing aims to control pressures in the well. The BOP provides a further level of security. When the well penetrates a potential reservoir rock, the oil or gas may be detected by analyzing the drilling cuttings for traces of gas and/or oil. At this stage, it is essential to gather as much information as possible about the reservoir. Two methods provide most of the information. In the first, the drill bit is replaced with a diamond-studded coring bit at the bottom of a core barrel. This can cut a complete section of the reservoir rock and return it to surface for detailed analysis. In the second stage, coring may be replaced or complemented by running a suite of geophysical logging tools, which are run on electric wire line. These are instruments that can measure the physical properties of the rocks as they pass slowly through the wellbore. When as much information as possible has been gathered from the reservoir, a decision is made on whether to complete the well for production, suspend efforts with the option to return to the well at a later date as more information on the reservoir becomes available, or to plug and abandon the well. If the well is seen to have production potential, the reservoir interval is lined with casing. The casing is then perforated to allow reservoir fluids to enter the well and travel up the installed completion production string to surface.